For question 19, we have two parts. First part, they're saying to prove sec to the power of 4 theta minus tan to the power of 4 theta equals to sec squared theta plus tan squared theta. First thing we can recognize is that this is a difference of two squares, so that would make it sec squared theta minus tan squared theta times to sec squared theta plus tan squared theta. This is the left hand side. So this is what we're left with when we apply the difference of two squares to this. And now what we can recognize is the identity of sec squared theta equals to 1 plus tan squared theta, as sec squared theta minus tan squared theta equals to 1. When you rearrange this, we can replace this as 1, because this is the same as 1. So now we're left with 1 times by sec squared theta plus tan squared theta, which is the same as just leaving sec squared theta plus tan squared theta. And therefore the left hand side, which was sec to the power of 4 theta minus tan to the power of 4 theta equals to sec squared theta plus tan squared theta. Once we've proved that, we can move on to part B, which you can do. With part B, in these types of questions, you can do them without doing part A, because it relates to part A already. So the interval is minus 180 to 180. And they've said sec to the power of 4 theta equals to tan to the power of 4 theta plus 3 tan theta. Somehow this relates to part A. So we need to somehow bring sec to the power of 4 theta minus tan to the power of 4 theta together. So what we can recognize is that we just have to bring this to the left to make it the same as part A. Equals to 3 tan theta. As we figured out, and as they told us in part A themselves, this is the same as sec squared theta plus tan squared theta, and this should equal to 3 tan theta. This does us no good because we can't really rearrange this into anything, as we can't use the identity to rearrange this, is what I mean. If it was sec squared theta minus tan squared theta, then we could just equate that to 1 using the identity over here. But as it's sec squared theta plus tan squared theta, we're going to have to do something else, and what we're going to do is we're going to use the identity to replace sec squared theta, because you can see we have two tans over here. Let's make another tan here. So sec squared theta can be replaced by 1 plus tan squared theta, as the identity is sec squared theta equals to 1 plus tan squared theta. So now that's replaced, we can put plus tan squared theta equals to 3 tan theta. We can see a sort of quadratic forming. When you expand the brackets, you're left with 2 tan squared theta plus 1 minus 3 tan theta equals to 0. Now, to make it easier for us, as I always will do myself, tan theta equals to y, so let's replace everything here. 2y squared minus 3y plus 1 equals to 0. Now we can just factorize. 2 times 1 is 2. The factors of 2, which add to give minus 3 will be minus 2, minus 1. So we're going to write this out, minus 2y squared, minus 2y, minus y, because it's minus 1, plus 1 equals to 0. And when we factorize this, 2y will go outside, then y minus 1. We do this side first. That's that factorized. Now we need to have y minus 1 on this side as well, and to make that happen, it has to be a minus 1 on the outside here, because this will times to give minus y plus 1. And then you just recognize these two outside will make 2y minus 1. Then the similar brackets will be the other one. And therefore, now we're left with, as y equals to tan theta, we're left with 2 tan theta minus 1 equals to 0, and tan theta minus 1 equals to 0. Okay. Now we need to solve for theta. We're going to put theta on its own. These are our equations we need to solve for. Right. Let's bring up the cast diagrams. For this one, we'll do number 1 first. Tan theta equals to half. As we're learning, we can see that it's tan, and this is positive, so it can only lie in the all region and the tan region. So we need to find these two angles. We can find the all angle, the acute angle, by doing the inverse to find theta. And when we do that, we should get tan minus 1 to the half. That's 26.5 degrees. 26.565 degrees. And to find this angle, we're going to do 180 plus 26.65. That should give us 206.565. Now, what we also need to recognize and remember is that our region was from minus 180 to 180. This falls outside the region, so we can discard this. Only this counts. Now if we go in the negative direction, where we go this way, the same cast rule applies. We have to look at this angle and this angle, but we're going to go this way now. So we have minus 26 over here, minus 26.565, but we want this angle. So to do that, as this is going to be minus 180, all we can do is, it's the same principle as if it was positive. So do 180 minus 26.565, and that gives us minus 153.435. As in, first do 180 minus 26.565, and then just turn it negative, because common sense dictates that if we're finding the angle over here before minus 180, it's going to have to be a negative number. Right, so that lies in the region. So for this number 1, our two angles are going to be minus 153 minus 153.435 and 26.565. Now for this, tan theta equals to 1, cast diagram again, we're going to be finding these two, because it's tan and it's positive. Find the inverse first. That's 45 degrees. So theta equals to 45 degrees. This angle over here is going to be 180 plus 45, but that's going to make it fall outside the region, so that can't count. But now we're going to need to go through the negative direction, so we're going to have to find this region, this region. This region is obviously going to be outside the region, as when we're going this way, this is minus 90, this is minus 180. Anything over here is more than minus 180, it's more negative, and therefore it's going to lie outside the region, as anything before this is too negative. So this is the region we're going to be finding. Should be a T. And as this is 45, or minus 45, or however you want to put it, to find this region, we're going to do 180 minus 45, which is 135, so the other angle is minus 135. So for the whole question, theta equals to minus 135. Minus 135 degrees, minus 153.435 degrees, 26.565, and 45 degrees.